Hi, and welcome to IV Tutor. We are looking at file streams in this video, and briefly, file streams are used whenever we want to read or to write from files. And the concept of streams is not like a new concept at this point in time, which means if you're watching this video, you already have been using cout, cin, to read and write input from the keyboard and write into the screen. So basically, a stream is like a channel that allows you to move data from one point to another as characters, just to make it easier to explain at this point. So when it comes to streams, we've got input streams and we've got output streams, but these streams can be of different types. For instance, if we talk about cin, you already have used cin to get input from the user, which means a cin is a stream that allows you to read or to move data from your keyboard into your variable. So if you declare an integer like this, right, and then you go cin and then you do that, what's happening here is we are now extracting data from this stream into this variable. And that is the reason why this is referred to as the stream extraction operator, right? Because it is extracting data from your stream and putting it into your variable. And this operator here points in the direction of data flow, which means your data is moving from your input stream into your variable X. So whenever you use cin, it means that on your console, it's going to wait for you to type some input and then you press enter. And then whatever you have typed, it's going to try and put that into the variable X, right? And likewise, so this is the C standard input stream. And likewise, we also have an output stream, which is your cout stream. So cin and cout are examples of inputs and are examples of an input and an output stream. And in this case, you would then do something like this. And then you can put like some text in here. And if you do this then displays on your screen, which means this is then referred to as the stream insertion operator. Why? Because it's inserting data into your stream, right? So, and again, I said these operators point in the direction of data flow, which means your data is moving from here and going into your stream. And your output stream is connected to your screen, which means whatever is there is going to display on your console. And your input stream here is connected to your keyboard, which means whatever the user types, on the keyboard, that is what we are going to then put in this variable X. So these are examples of an input and an output stream. But in this case, though, you want to talk about a different type of an input and an output stream. The reason why it's important to talk about the cin and the cout streams is because all input and output streams behave exactly the same way, which means you use them exactly the same way, which means the same way you have used the cin and cout, that is exactly the same way you are going to use input streams and output streams under files. The syntax remains the same. So it's good to remind yourself that, okay, if I'm using an input file stream, it's going to behave the same way as cin. And if I'm using an output file stream, it's going to behave the same way as the cout, only that the input file stream is used to read from a file, and the output file stream is writing to a file versus reading from a keyboard and writing to a screen. In that case, we will be reading from a file and writing to a file. And what we use there is going to be the if stream and the of stream variables, which means that this is equivalent to your cin, and this is equivalent to your cout. But it's which is input file stream, or output file stream, which makes it easy to remember. And these file streams are included in the f stream library, which means if you want to use file streams, you have to include, then you go f stream. And this allows you to then use output file stream and input file stream variables. And basically, the steps that we're going to take in order to use file streams are very straightforward. It's 5 basic steps Number one, you make an instance of your file stream, which means you make a variable of type ifstream if you want to read from a file, or a variable of type ofstream if you want to write to a file. That's your first step always. Then you open it. Now, opening your file stream means you are now linking it to the file that you want to read from or write to, which is the second step. The third step involves checking for errors. You check if this process was successful. Did we manage to connect this to a file? For instance, if you try to connect to a file that is already in use, this process can fail because it would say, or if you try and connect to a file that you don't have enough permissions for, this process may fail, which means we always want to check whether the operation was successful or not. Did we manage to open the file or not, right? And then after that, you can use your file stream to read as many times as you want or to write as much as you want. And then once you are done reading or writing to a file, from or to a file, you can then close your file stream. So these are the basic steps that are involved in using a file stream completely. And that is what you're going to try and break down. But eventually always remember and remind yourself that you declare a file stream variable, you open it, you check if the opening was successful, you read or write depending on what you want to do, and then finally you close your file stream. These are the 5 steps we always take with file streams, right? So we're going to look at basically just a breakdown of, okay, how do you declare, how do you open, how do you do this? But otherwise, file streams are for the most part very straightforward in terms of their usage. And before we look at the overall code that does all these 5 steps, like we're going to look at an example that does all these 5 steps from start to end. But before we do that, we just want to talk about a few functions that are important in understanding the code that we are going to be using. For instance, we are going to use a function here. Here we're just going to declare variables. That's it. We're going to use a function called open to do this. We're going to use a function called fail to do this, and another function called exit. Because what we want to do is check if the opening was successful using the fail function. And then if it wasn't successful, we want to exit, right? And then we want to read and write from a file. We will talk about how to do that. And then we are going to use the close function to close a file stream. So now let's just look at the exit function and understand what it does. And basically, it allows your program to terminate. And the exit function takes a number. And usually you give it a 1 if if there was an error, and you can use it as 0 if there was no error, everything was successful. So it's just an integer that you put in your code to the exit function. But if you want to use the exit function, which is very important because in most cases, when we use file streams, we use the exit function. You have to always include the C standard library. So if you see the exit function in your code, always check for this library. So some of the most common questions will ask you to include all the missing hash include statements, which means you know that to use file streams, you need to include fstream. Now, to use the exit function, you need to use cstdlib, which is the C standard library. So always remember to include this library if you want to use the exit statement, which we do use in most cases, all right? Now, the next thing we want to talk about is, let's say you want to write to a file, okay? Even though we haven't really looked at the code that writes to a file. There are 2 options that you get when it comes to writing to a file. You can either overwrite or you can append, right? Overwriting means every time you run your program, it's going to sort of like delete the existing file and recreate it. In other words, it discards everything that is already in the file. That's like overwriting, which means your latest output is the only output you're going to get in that file. But sometimes you want to run your program so many times, but you want to keep on appending or adding onto that file without overwriting every time that you run. This is what you're referring to here, right? So before we go into the details, this code here shows us 2 things that we're going to talk about anyway. Number 1, how do you declare a file stream variable? If it's an output file stream, if you want to write to a file, which is step number 1 before, you simply use ofstream, then the variable name. If you want to read from a file, it's ifstream, then the variable name. Step number 2, remember we said you then open the file. And to do that, you use the open function. This function takes 1 argument, okay, which is the name of the file or the path to the file. But for most of the questions that we do, we just assume that the file is within our project folder. So we don't have to specify like a long path. So you would see that we normally just put the name of the file. That is normally how you would do it. If you just close your bracket here, and then you put a semicolon and you don't do this, that means you're going to overwrite to that file, which means every time you run your program, it's going to overwrite this file. But if you want to append to the existing file, in the case that it exists, you simply use the open function again, but this time you give it two arguments. Number one, you give it the name of the file, and number two, you give it this directive, ios :app, which is short for append. So when you do this in the opening, step, it means that whenever you run your program, it's going to append to the existing file. That is one of the most critical things I want you to understand as far as step number 2 is concerned, which is opening your file, right? The next thing is, what if we want to use a variable name as our file name? Because remember, in this case, you can see that we are just putting the name of the file there. But what if we want to ask the user the name of the file that they want to connect to, or they want to read or write to? That is this step now. Like, what if the file name is input that is coming from a user? Well, it's a string, right? Which means you just make a variable and you give it to this function. But I want you to be very careful and always remember that you must use a C string. If you don't know what a C string is, go and look at our first video which covered C strings, because there are two options when it comes to using strings in here. We can use a string that is defined like this, or you can use a C string. So whenever you're using files and you want to use a variable for your file name, this must be a C string, which means I'll define my C string like that, which means that my file name should be at most 14 characters, remember, because the last character is going to be used by the null character. And then you can ask the user to type in the name of the file, so the user can type it in. Here we declare our file stream, and then we can open. If you want to append, you can still do the ios.app directive as the second argument. But the most critical point I want to highlight here is that if you are using file streams and you want to get your file name from the user or as a variable, remember to use a C string, right? And if you don't know what C strings are, please visit the video on C strings. Now, the next part I also want to highlight is the part where you read from a file, okay? And remember that I said your file streams they behave the same way as C in and C out. Now let's talk about C in, for instance. You know that C in will read up to the next white space, or will read up to the next end of line character. It doesn't read everything. If you want to read the whole line, then you have to go C in dot get line, right? If you just do this, C in always reads up to the next white space, which means if X is a string and the user types hello there and they press enter, X is going to be hello, that's it. Which means C in, every time you call it, it only reads up to the next white space or up to the next line feed or end of line character, and it stops, right? So what we are doing now in this case is we want to read from a file, right? We declare our file stream, we open it, right? Here we're going to check if the opening was successful, but we're gonna talk about that later, right? And in this case, let's assume that our file looks like this. It has numbers, one number on each line, which are doubles. And we want to read all these numbers and then calculate their total, for instance, right? You can identify the 4 steps that we talked about. Number 1, which is declare your file. Number 2, open it. Number 3, check if it is opened. Number 4, you read and do whatever you want to do. And number 5, close your file stream when you're done. Now we're going to talk about step number 4, which is reading, because in most cases when we read, we want to read everything in a file. So if we just go in stream, this is my bad. This should be in file, right? Sorry about that. This is our file stream. So this is in file, which is this variable here. Okay, just sorry about that. So if you want to read, remember your input file stream works like a C in. So you can see the syntax here that it looks exactly like just using a C in, your extraction operator, and then your variable next, which is the double. So we have declared 2 variables of type double, next and sum, and we want to read from our file stream. So you just use it like you use cin, which means whenever you do this, it's going to read everything up to the next white space, which means calling this once will read this number, right? Which means if you are not using a loop and you simply go here and you just go in file, then you go next. Let's say you had another variable, then you go X and then you go Y. This would read the first three numbers, which means the first one would be next, the second one would be X, the third one would be Y. But we haven't read the whole file. But we've actually read, right? That is how you would read. So in most cases, you realize that whenever we read from files, you want to read everything up to the end. So it is very common to just use a while loop, which will keep reading the next item until it has gone to the end of the file. Now, you may be asking, so how is this a condition? Because you're saying while in file, and then what is happening here? Which is very interesting because we expect a condition in our brackets, but we're just reading in here. The extraction operator can also be used in a Boolean condition. And the way it works is if it reads the next character and the reading was successful, it returns a true. So what is going to happen now is it's going to read this number into next and return true. And then it's going to do the sum, and then it will come back again. Now, the way a stream works is once it reads here, it doesn't go back to the start, it stays there, which means it then reads the next one and stays here, and it returns a true, which means now we've got the next number, we add that to our sum, it goes again here, it reads the next one, which is this one, and it keeps reading, returning true, true. And the moment it tries to read the next item and it doesn't find anything, it then returns false, which is how this loop terminates. So it's very common to see this operation being done inside a while loop, which is how you then read everything in a file by simply repeatedly calling your input stream and just reading the next item until you have read everything. That is one way of doing it. Another very important function I also want you to understand when it comes to reading using a while loop is the end of file function, which is commonly used to read from a file because it allows you to check if you are now at the end of the file. So another option to what I've just done is to use this EOF function, which you call on your in-file stream. So you go infile.eof, which means end of file. And this function will return true if your stream is now at the end of the file. So the way this is now working is you can see as an alternative here, sorry, this should be in file. As an alternative here, I can actually just read inside my loop, which is also fine. And I use my EOF function to check if I'm already at the end of the file. And remember, every time you read, your input stream keeps on progressing. It doesn't go back to the start of the file. It stays where it is. And then you read again, it goes to the next item. You read again, it goes to the next item. So what I want to emphasize on here is the EOF function, which is commonly used when reading files to check if you have reached the end of the file. Now realize that this function returns true if you are at the end of the file. So in our while loop, we want to say if as long as we are not at the end of the file, we want to keep looping, which is why you see that it's used with this not operator, because this will return true if it's at the end, which means as long as it's not yet at the end, we want to keep on looping. So it's going to say, are we at the end? No, which will give you a false. And then because of the not, this becomes true. So we keep looping until this says true. And because of the not, it would then become false and our loop will terminate. So this would then allow us to keep reading until we reach the end of the file. And another common variation also is where these two statements are put in brackets. And you will see that in the example that we're going to look at next. And now let's look at a complete example that just shows you how to read from a file and do stuff and write to a file at the same time and highlight those 5 steps that we talked about. The first thing I want you to see, I'm hoping that this font is good enough for you to see what's going on. If not, please go full screen. But anyway, so the first thing is, remember, we have included our most important includes, which is the F stream and the stdlib, right? Because we want to use the exit function, right? Step number 1, we declare our file streams. Here we want to read and write, so we declare two variables, an input file stream and an output file stream, right? Now, step number 2, we open here. Step number 2, which is also what we do, sorry, I left out, what did I do here? I left out one statement here, which is missing here. Anyway, we open our input file stream. Step number 3, which is now this part, we check if the open was successful. And the way you do that is you use the fail function, which will return true if the open was not successful. So what you are now saying is, okay, step number 1, let's declare. Step number 2, let's open. Step number 3, let's check if the open was successful. So you say if infile.fail is true. If this is true, then maybe show a message and then exit. This is how we use the exit function. So I've done this for my input file stream, and I'll repeat this for my output file stream. Again, step number 1, which is declare your output file stream. Step number 2, which is missing in this case, is ofstream.open. I don't know how I skipped that line, but you would have in between here ofstream.open, and then we can open our text file that you want to write to. And if we want to append, we can then use that directive as you saw earlier. And step number 3, again, we can check if the opening was successful. If not, we can exit. And this is the reason why, like I said before, we use the cstdlib. So these steps are very straightforward. Like there is nothing you need to think about here. This is always how you do it, exactly like this. There are no variations. It's exactly like this, unless your file name is a variable, in which case you must use a C string. But these are very straightforward steps. Where it becomes tricky is where you are reading, because this now depends mostly on what you are reading, and the code that goes here depends on what you want to do with the stuff that you're reading. So there's no one way of doing stuff inside your while loop, because this now depends on what you really want to do. And in this case, we just want to calculate the total of everything in the file, and that's it. So you can see that we declare a double quote total, even though I forgot to declare another double here called current. There's so many mistakes in this code, sorry about that. So you declare 2 doubles, total and current. And then what you then do, like you see in this case, I'm saying as long as we are not at the end of the file and we can read the next item, let's read. So remember, this is a Boolean, so this will read into current, and we can use the current item by adding it to our running total. And then we want to take that value and write it to this file. And remember, this works like cout. So in other words, we just say cout the current number and put a new line. So this is reading the current number, calculating the total, and writing it to the output file. And that's it. And eventually, step number 5, we just close our file streams. So that's basically how file streams work. And the reason why file streams seem difficult is sometimes it's because of the context. It's because of what we have to do with the items you're reading. Otherwise, the actual logic behind file streams and how they work is very straightforward. So sometimes they can say, calculate the average of everything, which means we need to be counting how many items we have. So we may have to put a counter in here. And then after that, we can then say total over the count, which then becomes our average. But that logic has nothing to do with file streams, really. It's just logic based on what you're trying to achieve. But if we talk about file streams, this is it. It's very straightforward. You declare your file stream, you open it, you check if the opening was successful, you read using a while loop for the most part, and then you do whatever you want to do with your items. If you're going to write, you write. If you're going to read, you read. And then once you are done doing whatever you need to do with the items, you then close your streams. And that's it. All right. So this is a very simple and straightforward example on file streams. But otherwise, we are going to see file streams a lot when we do classes, because what we normally do is we read an item from a file, and we make an instance of a class, and then we do stuff, and then we write to another file, and then so that complication, I want you to be very clear in your mind that it's not because file streams are difficult. It's just because the logic sometimes of what you're trying to achieve is difficult, so things can get really nasty in here sometimes, but otherwise file streams are not very difficult. And then one last thing I want to talk about, really, just to cover a little bit more ground, is the get and put functions, which allows you to read one character at a time. And this is not new. This is just like the way you see in, like, imagine if you want to read a yes, a y, or n character from the keyboard, You wouldn't use cin, you would use cin.get, right? So the same way you can also use get functions and put functions to read from your file one character at a time. So if you want to read one character at a time, you can just use cin.get in here. So you can go while in file.eof, and then you can go cin.get, and then in the get function, you put whatever character you want to get. So it works exactly like the get function. I don't want to talk much about the get function because this is not about get and put, it's about Filestreams. But what I'm trying to say here is that you would have like your usual while loop here. So you'd have while, let's say in file .eof, like that. And then in your while loop, you can then say, let's say you've got a char here called C. You can then say cin.get, then C there. And then you can do whatever you want to do with your character, check if it's a space or whatever the question requires you to do. And that's it. And then you keep going. Or if you want to write that character to another file, you can just go, I think it's cout.put, then you put your character and so on. So that is how you can use your get and put functions. And that's it. So you just have to practice. So in this video, we are not going to look at past exam questions on Filestreams because most of the questions that we encounter on Filestreams are based on classes. So what we're going to do is we're going to look at classes. And then when we look at past exam questions on classes, we will then cover Filestream examples together with that, because that is where we're going to see how this fits into classes. Because normally when they want you to use your classes, they want you to use them with Filestreams. So the two are sometimes married together. So we are not going to look at exam type questions in this video. So we're going to look at classes first. And then as we look at past exam type questions on classes, we'll then revisit Filestreams and see how they can be asked in an exam situation. Otherwise, Filestreams are very straightforward. So just do a refresher, go through this again, make sure that you understand the steps involved when using Filestreams. It's 5 steps: declare, open, check failure, read or write, close your Filestream. That's it. So that's it for this video. I'll see you guys in the next one. Cheers.